My name is Priyanka, and this is Milestone 3 of my 3-joint robotic arm project with a camera. This week, I managed to finish training the YOLO model and create the code to have the Raspberry Pi control the arm. When I was running the training for the YOLO model, I kept on running into an issue where the training would stop midway and never actually fully finish. This was because the Raspberry Pi wasn't capable of fully finishing the training. Therefore, I had to repeat the training process using something called Anaconda, which functioned on my actual laptop rather than inside the Raspberry Pi itself. I used the image and label files that I already created and reorganized them using Anaconda. The training successfully ran here, and I emailed the weights folder to myself so I could download it back inside of the Raspberry Pi. The weights folder was necessary so that the camera could actually detect the objects, based on the data it had collected. I was then able to run the final script, which would open the camera window and then detect the candy bars. As you can see here, when I hover the camera over the Snickers bar, it draws a box around it and labels it with a confidence rate. The code specifically tells YOLO to only draw the box if the confidence level is greater than 50%. The camera also recognizes the Twix bar successfully, but it does take a little longer for the camera to recognize it. This is the Python code that I edited in VS Code, which is used to send signals to the Arduino from the Raspberry Pi. Depending on which object the camera detects, the code will set one of the GPIO pins on, which then turns on the analog pin it corresponds to, since they are connected by wires. When the pin is turned on, this code in Arduino runs and has the arm perform a set of movements based on what candy is detected. So, if a Snickers bar is detected, the arm will rotate left, move back, and close the claw. If the Twix bar is detected, the arm will rotate right, move up, and open the claw. The void loop function tells the arm which set of movements to perform depending on which analog pin is set on. Here's a demonstration of the final robotic arm and camera. As you can see, the camera detects the Snickers, which then causes the Pi to send signals to the Arduino, then having the arm perform a set of movements. Throughout the past 3 weeks at Bootcamp, I've been able to gain more hands-on engineering experience and gain more technical skills. I was able to learn more about using servos, Arduino, the Raspberry Pi, and most interestingly, being able to use the Raspberry Pi to control the Arduino. Getting the arm to move based on what the Pi camera saw was definitely my greatest accomplishment since I ran into a lot of problems during the process, but I managed to overcome them. In the future, I plan on using the skills I learned at Bootcamp to further develop my project, for example, getting it to pick up some objects. And I also plan on using them in any other projects that I may plan to pursue in the future.